something dirty. Let me just do that. Okay, what's happening, y'all? Let's look at the left-hand side of our notes. We are on page 503. Go ahead and turn your books there to page 503. Your books should be turned to page 503. I might come around in a minute and make sure your books are turned to page 503. And let's look at number 6. Number 6 says, is this direct variation, inverse, or neither? With a couple question marks. So is this direct variation, inverse variation, or neither? And we're going to need to use those K tests that are on our chart. Let's go ahead and see here. It's 3, 8, 10, 22. And 15, 40, 50, 110. Okay, so let's go ahead and look at those K tests over there. See if either of them always come out to the same thing. Go ahead. Okay, I was a little ambiguous there. The K test, look, the first one says y over x. So does y divided by x, y divided by x, is that always the same thing? Or is y times x always the same thing? Or maybe neither. So for direct variation, y divided by x would have to be the same thing. And for inverse variation, y times x would have to be the same thing. Well, this doesn't happen. It's not inverse because if you multiply them, you don't get the same thing. But when you divide them, you do get the same thing. You always get 5, 15 divided by 3, and do the y coordinate divided by the x coordinate. That order is important. 40 divided by 8, 15 divided by 10, 110 divided by 22. This is kind of like the slope. Change in y over change in x. So y over x. Maybe that'll help you remember. So this is 5, and that equals k. K equals 5. That's great. And this says write an equation. So write your direct variation equation. So look at your chart there in your notes. Y equals kx instead of k. Write what it equals. There you go. And that was number 6. What do we got next here? Let's look at number 14. And we're getting 14 out of the way. It's a little trickier. It says they vary inversely. Write a function that models each inverse variation. Graph. Okay. Write a function, and then graph. Write a function, and that's just the equation. Write function and graph. Okay, so 14. Go ahead and try that. First, you got to find k, and then write an equation, and then try to graph it. Maybe we'll pause it along the way as we go. Go ahead. All right, first thing we need to do is find k. Well, for an inverse variation, k equals x, y, or yx. I'm looking at my notes there. The order doesn't matter. So for number 14, let me see, 1.2 and 3. Okay, so k equals 1.2 times 3, which is 3.6. So basically, my equation, whoops, let me not say basically. So I need to write my function, put 3.6 for k. Now when I'm graphing this, let's do it like the car problem. Let's try to find numbers that multiply to 3.6. Okay, we'll just think of numbers that multiply to 36 and put a decimal in one of them. So for example, 4 times 9 is 36, so 4 times 0.9 is 3.6. 6 times 0.6. Let me see what else is there. I guess we have 1.2 and 3. There we go. So let's go ahead and graph these points. So 4 and 0.9, 6 and 0.6, 3 and 1.2. We can reverse these as well. You can multiply in the other order. So 0.9 and 4, 0.6 and 6, 1.2 and 3. And we're starting to see this curve develop here. There we go. There's the graph of my inverse variation. Now, of course, these could also be negative as well, so I could draw the same curve down here, making the coordinates negative. Because a negative times a negative will give me that same positive 3.6. That didn't really apply to our car problem because we can't have negative people, but let me do a quick sketch of the other half. So it would look kind of like this. Beautiful. Okay, let's look at one more problem. I want to try number 20. And number 20 says the number of buckets of paint N needs to paint a fence varies directly with the total area A of the fence and inversely with the amount of paint P in a bucket. It takes 3 1-gallon buckets to paint 72 square feet of fence. How many 1-gallon buckets will be needed to paint 90 square feet of fence? So to write this out, I'm just going to kind of list a few facts and just come with me on this journey. Maybe I'll pause it every now and then as you're figuring it out as we go. So number of buckets is N. What else do we have here? Area is A. And P is amount in the bucket. Amount in bucket is P. So I'm looking at the information, I'm looking at the variables, and just writing it out. Now, I want to look at this sentence. The number of buckets, so we'll start with N. For varies, look at your notes. We're going to put equals K. Directly goes in the numerator. Inversely with P goes in the denominator. So keep those notes handy. So N varies equals K. A goes in the numerator. P goes in the denominator. Okay, there's your equation setup. Now it gives you two more things. We'll need to do two more things. First, they're going to give us some values so we can solve for K. And then we're going to use that value of K to solve another problem. So the first thing I want you to do is plug in the values kind of in the middle of the problem there and solve for K. Go ahead. Okay, it takes three 1-gallon buckets to paint 72. So to solve for K, divide by 72. So our new equation is N equals 1/24 times A over P. We solve for K, put it in the equation. All right, go ahead and do the very last part there. Okay, it says how many 1-gallon buckets will they need to paint 90? And that's 3.75. I suppose you could just buy 4 gallons, or you can buy quarts of paint as well. So 3 and 3 quarts you could do as well. So those are your examples for this section.